Good evening. Today we are going to start with first topic in calculus, that is limits. Limits will be followed by continuity and it will be followed by differentiation. Actually, the topic integration is not included in 11th standard syllabus, but we will discuss integration also because you require integration in physics. Actually, we have done all the three topics: limits, derivatives, and integration, though not in detail, uh, during that course, mathematical model, right? But I think there are 3 4 students who were not part of that team, so we will discuss calculus in detail again, right? You are supposed to listen to that recorded lecture which is uploaded on website. Okay. Actually, calculus deals with changes. For example, geometry. In geometry, we study different shapes, right? Then in algebra, we discuss operations, right? Arithmetic operations, multiplication, division, subtraction, etc. Similarly, in calculus, we discuss changes, instantaneous changes. Actually, there are two parts, differential calculus and integral calculus. We are going to discuss both. Uh, Let me explain the concept of limit first. See, this is a circle. In this circle, I will inscribe a polygon having n sides. Here n equal to 4. Suppose dn denotes the difference between area of circle and area of polygon inscribed. Clearly, area of the circle is greater than area of the polygon, so dn is positive. Now I increase number of sides of that polygon which is inscribed in the circle. You will notice that dn is now decreased, but still area of the circle is greater than area of the polygon, right? Now consider one hypothetical case, which is that every point on the circle is taken or considered as side of that n-gon. That is, we are considering a polygon having infinitely many sides, right? So in that case only, I'm repeating, this is purely a hypothetical case. In that case only, the two areas will be equal and the difference between areas will be zero. See, I'm writing dn. What does this mean? Will you say dn equals 0? No. You have to read this as dn tends to 0 as n tends to infinity. So if you increase number of sides of the n-gon inscribed in the circle, the difference between areas approaches 0. So 0 is the limiting value of dn as n approaches infinity. We write this as limit of what? Limit of dn as n approaches infinity equal to 0. Now every time we need not write limit, we just say lim. But while reading, we have to read this as limit only. Limit of dn as n tends to infinity is nothing but 0. Is that clear? Okay. Now I will give you another example. How will you define a tangent? Many students define tangent as a line which intersects the curve in only one point. This definition is wrong. See, this is intersecting, this line is intersecting the curve in only one point. So is this a tangent? No. So how to define tangent? Tangent is defined as the limiting position of a secant. I repeat, tangent is the limiting position of secant to the curve. Or you may say tangent is a line which intersects the curve in two but coincident points. I will explain both the points. Consider the curve PQ is secant to the curve. Now as Q approaches P, see, as Q approaches P along the curve, what is the next position of Q? Say this one. As Q approaches P along the curve, the secant PQ becomes tangent at P. See, this is Q1. Next position is this, say Q2. So as Q approaches P, the limiting position of secant PQ is what? Tangent at P. So I will say as Q approaches P, the limiting position is nothing but tangent at P, right? And therefore, tangent is defined as the limiting position of a secant. Now I said tangent is a line which intersects the curve into coincident points. See, this is parabola. I have already told you about this. This is parabola. What is the equation of parabola? Say y square equal to 4x. Generally, we take it as y square equal to 4ax, but here I have taken a as 1. So y square equal to x is the parabola. It can be seen that y-axis is the tangent at origin to the parabola, but x-axis is not a tangent. Now what is equation of x-axis? Y equal to 0. Put y equal to 0. You get 4x equal to 0. That is x equal to 0. So x-axis is not intersecting parabola in two coincident points. So x-axis is not the tangent. Now what about y-axis? What is the equation of y-axis? X equal to 0. Put x equal to 0 in the equation of parabola. That gives me y square equal to 0. This is a quadratic equation. It has two roots, but they are equal, identical. Yes. And that is why y-axis is tangent to parabola at origin. I hope you understood this. So what is tangent? It is nothing but limiting position of secant. Suppose I make a statement that train approaches Lonavala station. Train approaches Lonavala station. What inferences can be drawn? The first and the most important inference is the train is not yet reached Lonavala station. Why? Because I have said that the train approaches Lonavala station. That's it. Secondly, I have used the word approaches, right? So the distance between station, that platform and train is decreasing. So that is the second inference. And the third inference is again important. The direction is not mentioned. That is whether the train is coming from Mumbai or from Pune is not mentioned. But here we can say that limiting position of that train is nothing but that station platform. Okay. Now, in general, if I say x tends to 2, I could have taken 12, I could have taken any real number, but I have taken x tends to 2. What does this mean? This means that x is not equal to 2. When I say x tends to 2, important inference conclusion is x is not equal to 2 and therefore x minus 2 is not equal to 0. Because if x is not 2, how can x minus 2 be 0? And from this I can conclude that if x minus 2 is not equal to 0, division by x minus 2 is defined, is valid, right? You can compare this with that statement, the train approaches Lonavala station. First inference was the train is not yet reached Lonavala station. X tends to 2, so x is not 2, right? But x approaches values which are nearer and nearer to 2. Second inference or conclusion, x approaches values or assumes values rather which are nearer and nearer to 2. So the first value assigned is say 2.7. Then next cannot be 2.8. It can be say 2.6, then 2.1 up to 2.00001, very close to 2. The third inference is direction is not mentioned. That is whether x approaches 2 from left or from right is not mentioned. In fact, after 2-3 days, I will explain this concept of left hand limit and right hand limit. Today we will not discuss that. See here, you will notice that x assumes values to the left of 2 and approaches 2, right? It is possible that the first value is greater than 2, but x has to approach 2 only. So the third inference conclusion is x may approach 2, rather x, if it approaches 2, it may approach either from left of 2 or from right of 2. Okay, so we are now in a position to define limit. See, I will not dictate this theory part. In fact, we have already discussed the definition of limits, then rules of limits. So we will just discuss again that part, and I will upload the theory part on the website. Okay, what is the definition of, don't write, limit of fx as x tends to a equal to L. Before that, I will consider one particular example. Suppose f of x is x plus 11. Now tell me, if x approaches 10, now you will ask me why 10? If you don't like 10, consider 10,000, 11, any real number. As x approaches 10, x plus 11 will approach which number? Tell me. 10 plus 11, that is 21. So this 21 is called as limiting value of the function fx as x tends to 10. I write this as limit of fx. What is fx here? X plus 11 as x tends to 10 is nothing but 21. See, x tends to 10 should be written below this limit. This is not the correct way of writing. Many students, they write x tends to 10 and then they write LIM here. This is wrong. You have to write this as limit just before below L. You have to say x tends to 10. F of x is nothing but 21. Okay? Yes. Now we will discuss this definition. This means that as x assumes values which are nearer and nearer to a, as x assumes values which are nearer and nearer to a, f of x assumes values which are nearer and nearer to a real number, say L, then L is called as limiting value of the function fx as x tends to a. Symbolically, we write this as lim, but we have to read this as limit of fx as x tends to a is nothing but L. See, in the textbook, they have explained everything in the beginning only, and they have used the concept of neighborhoods to explain limits. Of course, we are going to discuss that, but not in today's lecture, because that concept, many students, they do not understand, and then they think that calculus is very difficult. It is not, right? So we will discuss neighborhoods in the next lecture, or maybe after 2-3 lectures. And then they have given one standard result. I wonder why they have mentioned one standard result in the beginning only. Of course, we have to solve problems which are given in the textbook, but I may change the order. Initially, you should be confident about evaluation of limit, and then only we can discuss different types. Okay. Now, before we start solving sums, there are a few simple rules on limits. Simple rules. The first one, or before that, I can say that suppose limit x tends to a, f of x exists and it is L. Limit x tends to a, another function g of x, this also exists, and suppose that limit is nothing but n, right? Now the first and the simplest result or theorem, you can say, that limit of sum is sum of limits. Means what? Limit x tends to a, f of x plus g of x is what? This is limit extends to a f of x, you need not write this, plus limit extends to a g of x. You will say obviously, but this is actually theorem. Now we have said that this is L and this is M. So what is limit of sum? It is sum of limits. So it will be limit of difference, simple, difference of limits. What will be the next theorem? I will say 3 because I have combined 2 theorems in first theorem. Then third can be, what is limit of product of two functions? That is limit extends to a f of x into g of x. Can I omit one step? It is limit of fx into limit of gx, that is L into M, right? Suppose one of the two functions is a constant, or before that we will mention next one and then I will tell you about limit of a constant. Limit of quotient, that is limit of f of x upon g of x, is obviously limit extends to a f of x upon limit extends to a g of x, provided denominator m is not equal to 0, because if denominator vanishes, it is not a real number, right? Okay. Now tell me, what is limit of constant, limit of any constant? It is that constant only. If k is a constant, as x assumes values which are nearer and nearer to a, k is not changed. That is why it is called as constant. And the important result is then limit of constant is that constant only. What will be limit of constant into function? Limit extends to a k f x. See, theorem is the same, that limit of product is product of limits. But what is limit of k? It is k only, constant. So k into limit extends to a f of x. Okay. So limit of constant into function is that constant into limit of function. Okay. Now, one important result, limit of composite function. Let me explain. Limit extends to a f of g of x. We have just finished the topic functions. This is composite. F of g of x is composite of g and f. So this is f of limit extends to a g of x. But what is limit extends to a g of x? It is m. So this is nothing but f of m. I will tell you one particular case, an important one. Limit extends to a log fx. What is limit of log? It is log of limit. So log of limit extends to a f of x. Okay. So all these are simple results. Now we are in a position to solve simple sums on the topic limits. Now write down evaluate. Write down. First one, limit of x square plus 4 upon x plus 1 as x tends to 4. See, every time you have to begin with let L be the given limit. Now, what is the meaning of this? See, as x approaches 4, we are interested in knowing x square plus 4 upon x plus 1 approaches which number? See, while evaluating limit, first you should think of denominator. Is denominator 0 on taking limit in the very first step? What do you mean by taking limit? By taking limit, we mean replacing every x by its limiting value. The answer is no, denominator is not 0. And therefore, we are in a position to evaluate the limit. Actually, in exam, such simple sum will not be asked. But if asked, then you have to say that what is limit of quotient? It is limit of numerator upon limit of denominator, provided limit of denominator is not 0. Yes, it is not 0. One more step is to be written, that limit of sum is sum of limits and so on. But here I have directly written taking limit. Replace every x by its limiting value. So 4 square, which is 16, limit of constant is constant upon 4 plus 1. So 20 upon 5, that is 4, is the value of the limit. Now many students ask me, sir, you are saying x is not 4, but you are putting x equal to 4 only. Yes, I still say x is not 4, x only tends to 4. But when I write 4, have I written x? No. This means I have evaluated the limit. And while evaluating limit, we have to put x equal to its limiting value only. See, I'm not saying limit extends to 4, 16 plus 4 upon 4 plus 1. No. When I write limit means I haven't evaluated the limit. And I have to put x equal to 4 only when I evaluate the limit. So what is the value of the limit? It is nothing but 4. Right up. See, calculus is fun. Yes, try this one. See, whenever you try, you should try on the rough page. So we begin with let L be the given limit. Now we would like to evaluate limit in the very first step for each sum, but that's not going to happen. Can we evaluate limit in the very first step? No, because denominator is 0, and therefore in bracket I have written for x equal to 1, we get 0 by 0 form. See, value of the polynomial is 0 at x equal to 1. Means what? X minus 1 is a factor of both numerator and denominator. See, you should know this so that factorization can be done easily. See what I mean by that. See, this is numerator. Now don't waste time in finding the factors because we know that x minus 1 is one factor. Second factor can be obtained easily if we know the first. X into which term is 2x square? X into 2x. Minus 1 into which number is plus 3? Minus 3. So these are the factors. What about denominator? Factors of x square minus 1 are x minus 1, x plus 1. Right? I repeat, we cannot and we should not take limit in the first step because we get 0 by 0 form. So the conclusion is as polynomial is 0 at x equal to 1, x minus 1 must be its factor. If we know one factor, second can be obtained by observation, right? Now substitute these and then see what can be done. So L equal to this. Now can I cancel x minus 1? Yes, I can. Of course, you have to mention the reason. X only tends to 1. X is not equal to 1. So x minus 1 is not equal to 0. Now many students forget to write limit x tends to 1. That is wrong. If you do not write limit, in that case, you have taken the limit. So x won't be there, right? So after cancelling, mention the remaining factors. Again, see, can we take the limit? The answer is yes, because denominator is not equal to 0. Now to take limit means to replace every x by its limiting value. Here I have omitted one or two steps like limit of quotient is limit of numerator upon limit of denominator and so on, right? And therefore, if you want to write, yes, you can. But here I have directly put x equal to 1 means I have evaluated the limit. So 2 minus 3 that is minus 1 upon 1 plus 1 that is 2. So final answer should be written in this form. L equal to minus half. Right now. Next one. Limit x tends to 3 of which function? 2x square plus 3x minus 27 upon 27 minus x cube. We'd have loved to evaluate limit in the very first step, but unfortunately we get 0 in the denominator. So it is better if we write this. For x equal to 3, we get 0 by 0 form. See, 9 into 2, 18, 18 plus 9, 27, less 27, 0. 3 cube is 27, right? So important conclusion is as poly is 0 at x equal to 3, x minus 3 must be the factor of both numerator and denominator. So factorization can be done easily. Now, what are the factors of numerator? First factor is x minus 3. Don't waste time in splitting middle term and so on. If first factor is x minus 3, second has to be 2x plus 9. Now take minus sign common. What are the factors of a cube minus b cube? A minus b, a square plus ab plus b square. So x minus 3 gets cancelled. Why can we cancel that? Because x only tends to 3, x is not equal to 3. Please write limit every time. After cancelling this, do not take limit directly. Mention remaining factors. Then see the denominator. Is it 0 on putting x equal to 3? No. So we can evaluate the limit. To take the limit means to replace every x by its limiting value, which is 3. So 6 plus 9, that is 15 upon minus 27. That is minus 5 by 9 is the answer right now. Now you have to remember this and use this as standard result. Limit x raised to n minus a raised to n upon x minus a as x tends to a is what? N into a raised to n minus 1. Actually, we are going to prove this result for natural index, but the result is seen to be true for any real index. So what is the standard result? Limit of x raised to n minus a raised to n upon x minus a as x tends to a is what? N into a raised to n minus 1. Now I will explain the proof. Put x equal to a plus h means we are using different variable h. Means h is what? X minus a. As x tends to a, h will tend to a minus a, that is 0. When we use substitution, we must find tending value of new variable, of course. So limit h tends to 0, a plus h raised to n minus a raised to n upon h. I have said that n is a natural number. So we expand this using binomial theorem. nc0 means 1 a raised to n plus nc1 a raised to n minus 1 into h plus nc2 a raised to n minus 2 h square up to what? H raised to n minus a raised to n as it is, denominator as it is. A raised to n gets cancelled. From remaining terms, I can take h common to get nc1 a raised to n minus 1 plus nc2 a raised to n minus 2 into h up to, as h is taken common, h raised to n minus 1. Can I cancel h? Yes, I can. Of course, I have to mention the reason that h only tends to 0. H is not equal to 0. After that, we are in a position to evaluate the limit. To evaluate a limit means to replace every h by its limiting value, which is 0. Only first term doesn't contain h. All the remaining terms, they do contain h or powers of h. What is nc1? N. So n into a raised to n minus 1 plus 0 and so on. So this is n into a raised to n minus 1. The result is seen to be true for all real values of n. See, there is one more method. On putting x equal to a, we get 0 by 0 form. Means x minus a must be the factor of numerator. If x minus a is a factor, the other factor is x raised to n minus 1 plus a into x raised to n minus 2 plus a square into x raised to n minus 3 up to a raised to n minus 1. In tomorrow's lecture, I'll explain the reason. You also try to find out this. Can I cancel x minus a? Yes, I can, provided I write the reason. X only tends to a, x is not equal to a. Now I'm in a position to evaluate the limit. To evaluate the limit means to replace every x by its limiting value, which is a. So a raised to n minus 1 plus a into a raised to n minus 2. Actually, a means a raised to 1. So add indices. So again, a raised to n minus 1 up to a raised to n minus 1. These are in all n terms. If you add a raised to n minus 1 n times, you get this only, n into a raised to n minus 1. Is that clear? So this is very important result. Now the first sum, exercise 7.1. Let L be the given limit of root z plus 6 upon z tends to minus 3. First, see whether limit can be taken in the first step or not. Yes, we can take the limit. Why? Because denominator is not 0. To take the limit means to replace every z by its limiting value, which in this case is minus 3. So root of minus 3 plus 6 upon minus 3. That is root 3 upon minus 3. What is this 3? Root 3 into root 3. So 1 root 3 gets cancelled. So final answer is minus 1 upon root 3. Second, limit of y raised to 5 plus 243 upon y cube plus 27, y tends to minus 3. Actually, you can say that for y equal to minus 3, we get 0 by 0 form. So y plus 3 is the first factor and therefore second factor is. But if this is y raised to 17, what will you do? Therefore, we have to use this approach. 243 can be written as minus 3 raised to 5 into minus 1. So I have written the same in required form. Same denominator, y cube minus minus 3 cube. Now I will divide numerator and denominator by y minus minus 3. Why? See, standard limit says limit x raised to n, or here y raised to n minus a raised to n upon y minus a. Here y minus minus 3. So that is missing. And in fact, it should be present both in numerator and denominator. And that is why we are dividing. Is division valid? Yes, because this is not 0. Now, what is limit of quotient? Limit of numerator upon limit of denominator. See, just a moment. Now I will say using, listen to me, limit y tends to a, y raised to n minus a raised to n upon y minus a is n into a raised to n minus 1. I hope you understood this. See, in the given sum, both numerator and denominator are of this type, but we need y minus a. That is why we have divided numerator and denominator by y minus a, right? Now tell me what will be the answer. So this is nothing but n means index 5 minus 3 raised to what? 5 minus 1 divided by 3 into minus 3 raised to 3 minus 1. That is 5 into minus 3 raised to 4 upon 3 into minus 3 square. So tell me, what is the final answer? Final answer will be just 15. Yes, 15 is the final answer. So you have to write this as L equal to 15. Yes. Sum number 3. Limit 1 upon z plus 1 upon z plus 5 as z tends to minus 5. I hope you won't say take limit in the first step because denominator vanishes in that case. How do we add fractions? By finding LCM, which is 5z. This is LCM. What is numerator then? 5 plus z. But originally z plus 5 is there. So you have to mention that also. Now can I cancel z plus 5? Same as 5 plus z. Yes, because z only tends to minus 5. Z is not minus 5. Right? So what remains on cancelling that is 1 upon 5z. Can we take limit now? Yes, we can, because denominator is non-zero. To take the limit means to replace every z by its limiting value, which is minus 5. So minus 1 upon 25 is the final answer.